Yes. Sige. Hindi na. Hey man. Good. How are you doing? Okay. Oh, okay. Uh-huh. Oh, you got no power right now? Like orange sugar maybe. Okay. Like thing that like computers and like I always have my weapon and stuff. And that's like what it's okay. I'm trying to learn it now, so I don't think I'll be able to like do it. Like I'm probably clean at 11. Okay. Like we were originally discussing, I think we're still a good time. Yeah, yeah. I just my morning got pushed back, so um I'm just really excited about this. Ones and things with that. Like crazy. I can't really get to no. Sucks. I really wish that didn't happen because if it didn't, I would have been able to do this with you now. Yeah. When do you think the earliest you can get on? 10:30. 10:30? You just want to shoot for 10:30 then? Yeah, sure. Sure. All right, man. I'm all ready to go. So whenever I'm gonna put the link on Zoom and you can just join or on school and you can just join when you're ready. Yeah, you're welcome. Bye. Look.
Hey Cameron, can you hear me?
Yeah, I can hear you. Can you hear me?
All right, good man. Good deal. Let me take care of one thing before we get started. I'll be right back.
Yeah, sounds good.
I'm going to start recording if that's cool with you.
Oh, that's good.
All right. So then you'll have this. This is to be posted on school. Where do you want to get started? Uh-oh.
Honestly, what's up? What?
Hold on.
Okay,
I have a little bit of a problem here.
take your time.
Okay, there's a lag. I think yeah, there might just be one little problem with the I think we're good. I don't know. If that echo comes back again, I'm gonna have to figure it out. But I think it was just a lag.
Okay.
All right,
Uh,
which one you want to get started with?
I mean, let's start it off easy. Let's start with just number 13. It says let fxy equals 2x. You just want me to read it off to you?
No, I got it. I'm looking at it right here.
Okay.
So number 13, you got f x y is equal to 2x cubed y minus y squared. And they want you to find the gradient of f 2, 1, right?
Yes, I believe so.
All right. So what is the gradient, right? It's just all these. We just need to look at the gradient vector of f of xy will
Isn't the
just be
grade?
go ahead.
Isn't that the gradient? Isn't that just like f sub x, f sub y, like the partial derivatives?
Yeah, it's just a partial derivative. So the first thing you want to do is figure out what that's going to be, right? You can do your f partial x.
That's simple. That's 6x uh 6x squared times y.
You got
Uh,
it. And
and then
f partial y.
that would be that'd be 2x cubed minus 2y.
You got it. Right. So now I can go f of x, f partial x 2, 1. So I'm going to plug in 2 for the x. So I like to go like this, man. Dummy proof it. I plug in 2 in for the x, 1 in for the y. That's 6 times 4, 24.
Yeah.
All right. Um, I want to make sure I'm looking at the right. Give me one second. I'm going to scroll down to my. I'm going to double check my solutions while I do this because sometimes I do make little mistakes.
You're good.
Okay, so that's 24. And then we'll do f partial y at 2, 1. And that'll be equal to 2 times blank cubed minus 2 blank. My x goes in here, that's a 2. My y goes in here, that's 1. Because you know, when you're taking the test, right, you're not really in the right frame of mind. You kind of, you know what I mean? It's
Yeah.
like mistakes are really easy to make. So that's why I practice that way. I practice like putting blank spaces in where my variables are, so I don't have to think about everything in one step, right?
Yeah.
So now that I have this 2, 1, I could just put these values in here. I got 24 and 14. So you can see how, like, if you do, as far as a gradient vector is concerned, if you know how to take your partial derivatives and you know how to set this up, right? It's no big deal. You can repeat this process a couple times just with this one problem right here and get all the results you need.
Yeah. That seems really easy.
Yeah. Super easy, man. But here's the trick, you got to remember it,
Yeah.
right? And what happens when we go to take the test? when you go to take the test, you're like all over the place, right?
No,
Like
yeah.
your brain is just in a million places, and you're like, what's going on? You know, there are tricks you can use to because you go sympathetic. Your nervous system goes into the sympathetic nervous state when you go into a test, and that's the last place you want to be. You want to be parasympathetic. So there's tricks you can do to trick your brain to go sympathetic, parasympathetic. Yeah, like binaural beats or gratitude lists or stuff like that. All right, what do you want to do next?
Could we do number 17?
Make sure I got this one written down correct.
It's 3 parts, ABC.
Yeah. 17. Okay, so 17
I'm gonna write
is,
this down with you. Just
yeah, whatever works for you, man. So there's gonna be three of these guys. F is equal to x squared plus xy plus y squared plus y. And they want to know max and min, saddle points, all that good stuff, right? So do you know your second derivative test?
uh to be honest with you, I know I just don't remember the name. Like I think I would just need like a reminder. It's
Yeah,
like
that's where when you have your critical points, okay, once you get your critical points where f partial x of AB equals 0 and f partial y of AB equals 0, this is your critical point. So your CPs are A and B, right? So all you got to
oh,
do here is take D of AB. This will be the function f partial XX of AB times f partial YY
oh yeah.
of
Uh
AB.
times
You
fyx squared minus fyx squared.
you want to have this on the ready, like you know exactly what to do. So if D is, how's it go? If D is greater than 0,
I believe so.
what happens when D is greater than 0?
Uh it's a minimum. No, it's
So
maximum.
so we've just identified a problem, right? This is really important, right? This is like a crucial
Wait,
step.
no, no, isn't it saddle point?
Give me 1 second here. No, so don't guess, right? Because every time you guess,
Yeah, I
what are
guess.
you doing, right? You're reinforcing that you don't know for one, and you
Yeah.
might be saying something incorrect. So when D is greater than 0, this means you have a max or a min. This means that you got a
Okay.
max or a min. Okay, now think about this for a second. When your f partial xx of AB is positive, positive, right? That's concave up, isn't it? That's a min right there. All
Yeah.
right. And then when your f partial xx of AB is less than 0, that's a sad face. That's a max. Okay, so what you want to remember here, right? What you want to remember is that when D is greater than 0, you got a max or min, so you got to check those other points. And then when D is less than 0, that means a saddle. Okay, so if you take 60 seconds and you just repeat to yourself for 60 seconds what I just wrote, right? You probably repeat it like 4 times. And that's really all you need. So it's all about repetition, right? Because we don't learn math, we just get used to it. Right. So I'm just going to repeat this stuff. So when I'm going to have a very specific algorithm, right, for
Yeah.
this. So I'm going to say, all right, the first thing I'm going to do is take f partial x. That's going to be 2x plus y, right? And the second thing I'm going to do is take f partial y. And that's going to equal x plus 2y plus 1, right? And I'm going to set both of these guys equal to 0. All
Okay.
right, so far so good.
Yeah.
Take a step back, double check it. Right now, from the first, and now you just bounce back and forth between equations because you want to get every x and y that makes both of these equal to 0 simultaneously, right? So I'm going to go into the first equation, and from the first equation, I see that 2x is equal to negative y, or negative 2x is equal to y. I have that relationship. So from that relationship right there, I then go into equation 2. So you just bounce back and forth between equations. So you go into equation 2, and you've got x plus 2 times negative 2x plus 1. equals 0. You see that? Like I just substituted into it. I took equation 1, got a relationship, substitute that into equation 2. Now I'm going to solve equation 2, right? And so this is going to be x minus 4x plus 1 is equal to 0. So this is going to be like negative 3x equals negative 1. X is equal to 1/3. Does that make sense?
Yes.
So now that I have that from equation 2, I go back to equation 1. So you just bounce back and forth between equations. So negative 2 times 1/3 is now equal to y. So y is equal to negative 2 over 3. Those are your critical points. Those are your critical points. You see that?
Yeah.
And now all you got to do is your only CP, your only critical point that you're going to get. I bounce back and forth, right? If I do that, if I cycle through that one time for each of the points that I get the first time through, I'm going to get all my points. Everybody gets worried, like, am I going to get all my points? You're going to get all your points, right? If you do it exactly how I just did it. Okay.
Okay.
So now I have my critical points. So what do? I have to take f partial xx, right? Because I want to build the second derivative test. F partial xx, if you look closer, that's just 2.
Yeah.
F partial yy, that's just 2.
Yeah.
You got it, right? And f partial xy is equal to 1. And I'm just going to check that f partial yx is equal to the same thing that f partial xy is, right? And that's equal to 1.
Yeah.
So I don't even need my point here. See, when I do d of 1/3, negative 2/3, I'm taking f partial xx of these 2 points, 1/3, right?
Yeah.
Is this going to matter at all?
Not
Are
really.
the points are not even going to matter, right? I can just plug this in
It is
just
2
to show
times 2
how silly it is.
minus 1 squared. Isn't that right?
Yeah, so I'm just being silly right now. I'm plugging this in, right? There's like really no sense in it because this is going to equal 2 times 2 minus 1 squared. And that right there, all I care is that it's a positive number. I care that it's a positive number, and that tells me I have a max or a min.
Yeah.
So now all I got to do is check my fxx at that point, which is going to be equal to 2, which is greater than 1. That is a happy face min at the point 1/3 negative 2 over 3. And then you just got to repeat that exact same thing for the next problem. And then for the next problem. So
Yeah.
every time you do this, you don't want to focus. I mean, it sounds silly, but you're not focusing on the math. Like, I don't care about the math. I
Yeah.
care about the uh, algorithm, the procedure.
Okay.
You know what I mean?
Yeah.
It's like you're doing a skateboard trick. You're learning to ollie. You got to wheelie, and then you got to hop, and then you got to wheelie, and then you got to hop, and you learn how to wheelie, and you learn how to hop, and then you put the two together, and you wheelie hop, and you do that a bunch of times, right? Until you nail it, right? And then you can start worrying about looking cool, right? It's all about the procedure first, right? I want to pay attention to the math because that's when we get the test back and we realize, oh, I got all these problems wrong and they're silly mistakes because I wasn't paying attention to math, right? So when you get this down to where it's muscle memory, then you can start focusing on the math. See what I'm saying?
Yeah, I do.
Yeah. All right, what next?
Um, let's look. Let's can we do number 19?
19, you got it. Okay. Did he do a lot of you know how they like on 18, you got to do these edges? Did you notice that? Like there's some of them that are on an absolute interval. Remember how we had absolute max and min back in calculus 1 and we had to find the critical points and then check the endpoints and any critical points inside the endpoints? Does that sound familiar?
Yeah.
That's like 18. So instead of checking endpoints, you're checking the end functions, right? A lot of teachers just throw that in the practice test, but they don't really talk about it during the year. They don't give many problems on it, and they don't really, I can't see Titan really caring about that problem, but you definitely want to know how to do it.
We
right?
should
That's called your
definitely yeah, we should probably cover that one next.
yeah, that's your absolute maximum. So what we just did with the second derivative test is like, remember in Calc 1, you get your function is defined everywhere. You take the derivatives, you get the critical points, and you see, if it's increasing, decreasing slope. If it's increasing, decreasing, it's a max. If it's decreasing, increasing, it's a min, right? Remember that
Yeah.
from Calc 1? Then you had ones where you had endpoints and you had to find the critical points and then check the values of the endpoints and check the value of the critical point that lies within those endpoints. That was way back in Calc 1. That's what you're doing with absolute max and min, like on problem 18. We'll talk about it. Okay. This one
Right.
right here, this is Lagrange multiplier. This is real easy, man. What you got to do is set up three equations. I'm going to do equation one. That's where I'm going to say f partial x is equal to lambda g partial x. And the one equal to the constant is always your g. Your g
Would
is going to
that
be your constraint.
be wouldn't the actually never mind because that makes sense. I just remember the equation as like the gradient of and that makes sense. So since this is like just like for the x.
Yeah, what we're going to do is take the gradient of f and set it equal to lambda gradient of g. And g
Yeah.
is always your constraint. G is always the one that's going to be equal to the constant.
Okay.
Okay. So then you just go, all right, this is 2x equals lambda 2x. Easy. And then here, equation two, you're going to go f partial y is equal to lambda g partial y. And that one is going to be negative 2y is equal to lambda 2y. Easy, right? And then your equation three, if you have two variables, your equation three is just your g. You're just going to write your g of y right here. Okay, so what you're going to do with these two equations up here is you're going to get a relationship between x and y. That's all you need. So what you can see here from that top one, it's kind of strange, isn't it? Right? Like you've got the top one tells you that, basically,
Lambda equals 1.
yeah, but you don't really want to say that,
Yeah.
right? But you do have lambda is equal to 1 and lambda is equal to
Negative
what down here?
-1.
It would be negative 1. So that's kind of like, huh. I don't really like to mess with my lambdas. Okay, so here's what I'm gonna say. When you get a situation like this, okay, from equation one, you have two cases. Either x is equal to 0 or lambda is equal to 1. Okay, because that could happen, right? If x is equal to 0, you don't even know what lambda is. Lambda can be anything. So you have an either or situation here.
Okay.
Okay, so what I'm gonna do is say case one, x is equal to 0. If x is equal to 0, I go into equation two. And what does that mean for equation two?
Uh, I don't know. It doesn't exist because
Hey,
this is
it doesn't make any sense. Here,
yeah.
let's do it like actually here, let's go like this. Let's go let's say case one is lambda is equal to 1. Let's just do that, right? And so uh oh, well, let me make a little note here too. Equation two, we have a similar thing going on. Lambda is equal to negative 1 or y is equal to 0. Okay, so case one, when lambda is equal to 1, this is from equation. Okay, so case one is in equation one. I know it looks ridiculous, man, but you'll get used to it. You just got to keep saying it to yourself. Case one, lambda is equal to 1. So then you go into equation two, just like we did in the last example, the last problem, right? I'm going to go into equation two now. And what this means is negative 2y is equal to 2y. Well, the only way that's happening is if y is equal to 0.
Yeah.
Okay. So if y is equal to 0 from the first one, then you go back and you look at, all right, uh, go into equation three. Go into equation three and what you have for equation three, because I can't go back into equation one because lambda equaling 1 tells me nothing about the x. So what I do here is I say, all right, well, lambda is equal to 1. That means y is equal to 0. I don't know what x is. In equation three, x squared plus 0 equals 1 tells me that x is equal to plus or minus 1. So now I have two critical points. This is going to give rise to two critical points. I'll have 1, 0 and negative 1,
Yeah,
0. You see that? So that's from case 1.
that's understandable.
Now I'm going to do case 2. I'm going to do case 2. I'm going to go into the other equation and I'm going to say equation 2, lambda is equal to -1. Now, when lambda is equal to -1, what does that have to say for equation 1? That means that 2x is equal to -2x. Well, then x is
So
equal
X
to
is gonna have,
0.
yeah, X has to equal 0.
And then you go into equation 3. See, because they're all saying it's saying the same thing. When I say lambda is equal to 1, I'm saying y is equal to 0. When I'm saying lambda is equal to -1, I'm saying x is equal to 0. So now I have y squared is equal to 1 in equation 3 because your x is 0. So y is equal to plus or minus 1. So this gives me 2 more points. This gives me 0, 1, 0, -1. Make sense?
Yeah, I'm sorry. Like, right? I don't know. I don't know. Like 3 lines up, where it says the three i's, then the x squared plus 0 equals 1. Is that
Yep.
equation 3? Or
That's
is,
equation 3. That's x squared plus 0 squared. This is 0 squared. That's your y. Your y is 0 now.
oh,
And
okay.
then down here in equation 3, we did 0 squared for your x. Y squared is equal to 1. So I'm plugging these into equation 1.
Oh, okay. That kind of makes sense.
Yeah. Let me see one thing here. Um, okay, that's good. Let me just check one more thing here. Hmm. I just got a little to go issue I'm trying to deal with real quick. Okay, good. We're good. How you feeling about things so far?
I feel pretty good. I don't know. I feel like it'll be hard from time to time to like remember like what thing to do, you know?
Oh
Um,
yeah, absolutely.
um,
That's the name of the game, right?
yeah,
So
it's
when you're looking at a problem like this, what you want to do is when you're done with it, you want to stop and go back and talk yourself through what you did a few times because it's not going to stick, man. You can't just do this once and be like, I got it, right? No way,
yeah,
right? You want to look at this and go, all right, what did I do again? So the first thing I did was I took the partial derivatives, right? I did the gradient vectors. I did the two gradient vectors, and then I did my constraint. And I said, okay, look at the top one. What conditions make that equation 1, 0? What conditions make this 0? Well, lambda is equal to 0, lambda is equal to 1. And then I look at equation 2 and I say, what conditions make that 0? Okay. So I have a case by case basis. And then I do one of these, right? And then I find out in the end, that's this case right here. That's y is equal to 0. That's what I find out in the end. And then so I go to the other one and I say, okay, well, if I take lambda equal to -1, that gives me the same condition as x is equal to 0. Right. And
yeah,
I go 1, 2, 3, 1, 2, 3, 1, 2, 3, like a dance. Right. See, I went from 1 to 2 to 3. And then in the second one, I went 2 to 1 to 3. So everything gets its turn. And now I can be confident that I've got all my critical points. Right. That's
yeah,
it. So the more I talk myself through this, the more confident I'm going to feel. Because right now it feels fast and loose. It feels like, oh my gosh. I mean, like, I don't know if I'm doing this right. I don't know, it just feels unfamiliar. And that unfamiliarity is what is confusing about it. That's what messes with our head. Anything, remember we talked about last night on the phone, anything unfamiliar in my environment instinctively is going to make me feel uncomfortable.
yeah,
Yeah. So I want to make this familiar Because whenever we're doing mathematics, what we're dealing with is primal fear. Every time, right? If I say you're gonna pass or fail this semester based on whether or not you can read this Chinese sentence, and I'm gonna stare at it and go, oh my God, I'm screwed. That's the first thing I'm gonna do when I look at a Chinese sentence. I'm gonna think, oh my God, I'm screwed. But I
Yeah.
take each character and I rewrite it and I say it and I rewrite it and I say it, and it turns out I'm fine. This is Chinese right here, right? Right. So if I talk myself through this a whole bunch of times, I just keep talking through it and talking through it and talking through it. It's going to be familiar to me. And then I'm going to start to understand what's really going on. Right.
Yeah.
Now, what you got to do at the end here is you take f of these values. So notice if I take f of 0, 1 or 1, 0, let's take the first critical point. I'm going to plug that in to my actual functions. We can break this down into 3 steps. We got step 1, step 2, step 3. This is how you want to think about it. Your mind thinks in these ways, like in steps, right? And this is going to be 1 squared minus 0 equals 1. And notice the same thing for -1 because they're squared. These are both squared, so your -1s and your +1s are going to equal the same thing. That's 1. Right. So if I do f of 0 plus or minus 1, I'm going to get the same thing 0 squared minus plus or minus 1 squared. Right. That
Yeah.
equals -1. So you look at which one's bigger and which one's smaller. Right. This one is greater than 0. This one is less than 0. So my max is going to be the bigger one. So I have a max at my critical points 1, 0 and -1, 0. Oh, wait. Yep.
Yeah.
And then I'm going to have
put it
a
up
min.
there. Yeah.
Yeah, you get it.
I get it. It's at 0, comma, plus or minus 1.
So now that you get it, see, now that you get it, you got a tiger by the tail. So what I'm going to do is take about 10 minutes and I'm going to talk myself through it as many times as I can for 10 minutes. And then I'm going to move on to the next problem. I'm going to do that same thing with the next problem. Or
Okay.
maybe 5 minutes. You spend 5 minutes talking yourself through. Okay, I got this. I got that. And you talk out loud with conviction. I can have all the crazy thoughts in my head I want all day long, but it's until I go down on 4th Street and start screaming them, that's when I'm going to have serious like repercussions. Right?
Yeah.
That's when they're going to have an effect in the world. It's not inside my head. Right?
Yeah.
So you just keep saying it to yourself and saying it to yourself. Yeah. And then you practice the next one, and the next one is going to have the exact same steps, and you're going to go, oh, this is the same thing I'm doing before, except you get these different conditions. Like when we did this last one, 17, different functions will give you different possibilities for what could happen up here, right? And then different functions will give you different possibilities for what can happen up here. So you're going to do the exact same steps for the second one, for part B. You're going to do the exact same steps, except it's just going to look a little bit different. But what you'll notice is that there's only the reason he put 3 on here is because there's basically 3 different types of setups for this, or not 3 different types of setups, but 3 different possible situations that could happen when you're taking your partial derivatives and setting them equal to 0, or setting them equal to 0 in the max min problem 17. This one right here, we're setting our gradient vectors equal to each other, right? So I go f partial x is equal to lambda g partial x, and that's going to be y is equal to lambda times 8x, right?
Yeah.
And right off the bat, see, I have a relationship between x and y. That's all my goal. So you might want to think your goal, your in part 1, right? Your goal in part 1 is relationship. X and Y. You want a relationship between X and Y. That is the goal here, right? So I'm going to take F partial Y, and that's going to be lambda G partial Y, right? So this will be X is equal to lambda 2Y. So I can see here that I'm getting something. I'm getting some kind of relationship. And then this equation right here is my constraint, my G. That's my G. G is always your constraint.
Did you use like the whole equation?
What's that now?
You said that like G's the whole equation.
G is like the equation where it's equal to a constant. That's
Yeah.
always going to be your constraint. G will be equal to constant. That's how you can tell what your constraint is. F is going to be the function to deal with. And they might, I doubt Tynan would do this because he's not like this. But I mean, I could call my G of XY equal to my function. And then you'd be like, well, what's G? The other one that you're multiplying lambda by, that's the one with the constant.
Okay.
Call it whatever you want, right? So I'm going to do the exact same thing again. All right. I already have my relationship set up. I already know like these two guys, that's a relationship between X and Y right there. I've
Yeah.
got it. So how am I going to deal with this? Well, I can do the same thing I always do. I'm going to take equation one into equation two, and then I'll probably take into equation three.
Yeah.
So if I take that y is equal to lambda 8x and I plug that into x is equal to lambda 2 times y, lambda 8x, right? Now
Yeah.
I might get something here, right? Now lambda is just something I use to lambda is something I use to help me relate the two variables. Okay, so watch what's going to happen here. Okay, I'm going to say x is equal to 16 lambda squared x. Now, if x is not equal to 0, I can divide by it. If x is not equal to 0, that's important. X is not equal to 0, I can divide by x and get 1 over 16 equals lambda squared. Lambda will equal plus or minus 1/4. That's when x is not 0, right?
Yeah.
Now I went from equation one into equation two. Now I'll take that information and I'll go from equation two back into equation one. And what's that going to give me? That's going to give me y is equal to plus or minus 1/4 8x. So I have y is equal to plus or minus 2x. You see that?
Yeah.
Now I've got a relationship. Now I've
Yeah.
got a relationship. Okay, so let's just say case one. Case one,
What
y
do we
is equal
want
to
to set
positive.
equal to 0? Or
What's
like,
that?
what do we want to set it as like equal to 0? Like y negative y plus or minus 2x equals to 0, like we had for the other equations when it equal to 0.
Uh,
I don't know. I don't know. If that's just completely wrong, just let me know. Like it might just
if
be completely off topic.
if x, so you're saying if x is equal to 0, because we said x is not equal to
No, no,
0
no, no,
earlier.
no. No, no, no. I mean like the equation, the relationship that you just said. Like I was just saying like 0 equals to negative y plus or minus 2x. That's what I was saying. But
Oh, you're going into you're going into equation three.
yeah,
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 yeah, okay. You're a step ahead of me, man. Okay, good. This is good. All right. So yeah, if I go up here, I can say 4x squared plus 2x squared equals 8. Good. So you've
wouldn't that
got
be minus? No, wait, no, never, never mind, never mind.
I'm
I
taking the plus
tried
case.
I if you see my, can I like react to stuff on here, or I don't know. Like,
What's
never mind. I was confusing some stuff around, but you plug that back into the equation, so that makes sense.
I plug it into equation three? Yeah.
Yeah,
So if that's true, see what I just did was I took y is equal to 2x. So now that's going to give me a couple critical points. When x is equal to 1, I'm going to get 2. When x is equal to negative 1, I'm going to get negative 2. That's what we get for this case,
that's the
right?
points.
And then case 2, is when y is equal to negative 2x. That's going to give you the same thing because when I plug this into equation 3, I'm squaring it. See,
Yeah,
I'm
because
squaring it. And so this is going to be
four.
uh, 4x squared, good, plus negative 2x squared equals 8. Same. This is same. This is the same as before. This is going to be 4x squared plus
It'd just
4x
be
squared,
8x squared.
right? So x is going to equal, x squared will equal plus or minus 1 again. Same. That's the same thing we just did. So see, because y is equal to plus or minus 2x, that's exactly what I have right here. I already have the whole thing right there. X is equal, this is both y is equal to plus or minus 2x. So when you do that again, it's like you're checking it. You're like, yep, I did it right. I'm right on, man.
Yeah.
I got this. 71.2. Right? Okay, good. Good. So now you have two critical points to check. So what is your F? Your original F is F. So this is part 3. So we did 1 and then 2, and now we're doing 3. And 3 is just go back and check these points. F of xy is equal to xy. So I'm going to put F of 1, 2 in there, and I'm going to get 2. And then I take F of -1, -2, and I get 2. Right?
Yeah.
Okay. That's interesting. But y is equal to plus or minus 2x. That also means, whoops. Okay, let's go back here. This is x is equal to plus or minus 1. There's one more thing I got to do here. That right there set up a big red flag for me. Those are both equal to the same point. That's neither max nor min. I'm going to go like this. Wait. If y is equal to plus or minus 2x, I'm also going to get the point. Look at my last points. I'm going to also get the point -1 and 2 and 1 and -2. Those 2 points are going to pop up too, aren't they?
Yeah.
Yeah. So I could have just taken these 2 points and plugged them in right there and got my new set of points. But what the big red flag for me was these two were the same. That tells me I'm not finished. I got to go back and look again. Right? So now I've got to check those other 2 points too. I've got to check F of -1, 2, which will equal -2, and F of 1, -2, which will equal -2. So this is my min, and this is my max.
Okay.
See, if you only get one set of points, it's kind of like, oh, wait, I ain't done. I'm not done. Because you can't compare one set of points. I mean, you can't compare one output value like that. You got to max, if I have this, well, what's that bigger or smaller than?
Uh,
Right? These are both 2. That's not bigger or smaller than anything. I have to have a contrast.
yeah.
That's what made me say, wait a second, if y is equal to plus or minus 2x, given these points right here, that also means that, plus or minus y is equal to 2x. That gives these points too. So when you get this symmetry, you tend to get symmetric points. Look at this symmetry, man. It's all over the place. I have squares, I have x times y, right? That's going to probably give me 4 points.
Yeah. Sorry, I'm just trying to follow you on my download thing too. Why is it so blurred? I don't know how to fix that.
Is it
Oh, blur
blurred on the
it.
Zoom screen?
Yeah, I'm just scrolling through like the good notes that you sent me. No, you know what it is. You just like the good notes you sent me. I'm trying to scroll through it right now and try to like
You mean
follow
the thing I post
the PDF.
yeah, did I
Solutions.
post that?
What's that?
The one that I posted on school last night?
Yeah.
Yeah.
I just have it in the background. I'm just trying to like I don't know, trying to like because I'm following you. I'm just like trying to get like my it on the page.
Yeah. No, that makes sense.
Yeah, but that makes sense. And then would that be for all 3 of them or just like part C or like one part?
That's part B. We just finished part
Yeah,
B. So
that's what I thought.
there's 3 of these. And then they give you 20. 20 is a Lagrange multiplier too. But you're going to use the exact same steps. And as long as you're bouncing back and forth, just make sure you're bouncing back and forth and checking all your possibilities, all your cases. You're going to be good.
Okay.
Yeah. Yeah. What else? we got here?
Uh, like another question?
Yeah, any other question? Anything you want to do, man? Do you want to go back and do that absolute max and min 18?
Yeah, and then possibly 16 after that.
16?
If we have time.
Yeah, what would you rather see?
What's up?
What would you rather see, 18 or 16? 16 is a completely different topic. Let's look at 16, then we'll come back to 18.
Oh yeah.
I would think so. He's got to use his time wisely when he's giving you this test. I would give you max and min in Lagrange. I would not give you 18. Right? But we should still know how to do it. We just want to prioritize Lagrange and second derivative test over. I'd say second derivative test first, Lagrange second, and the third on the list would be number 18, which is an absolute max and min.
Okay.
Does that make sense?
Yeah.
All right, let's check this out. See what we got here. One second.
You're good. I'm just writing this stuff really quick on here.
Yeah. Okay. Number 16. Number 16 is find the tangent plane to the normal line. Find the tangent plane and normal line. Find the tangent plane and normal line to this equation right here. This is a sphere, isn't it? We don't need to
Yeah.
know this, but if you check this out, this is, I mean, it's an ellipsoid
Yeah.
centered at 2, 1, and 3, right?
Mhm.
And they want this at the point 3, 3, 5. A tangent plane is just like a regular. Okay, let me give you a quick rundown of like a tangent plane. If I've got a surface, right, some kind of surface like this, and I've got a tangent plane. And a tangent plane is just like a tangent line, if it's going to touch, you got like a basketball and you take a piece of cardboard and you just touch that cardboard on that basketball at one single point.
Yeah.
Now, every plane has a normal line. Every plane is defined. It's defined by its normal vector, isn't it? And that n could equal like a, b, c, right?
Yeah.
And if this point is like p naught, and p naught is x naught, y naught, z naught. Okay. Now, if I draw this, if I make, the equation of a line, the equation of a line is always a x minus x naught plus b y minus y naught plus c z minus z naught. Okay, equals 0. That's the equation of a line or a plane. Sorry, that's the equation of a plane with the normal vector a, b, c at the point x naught, y naught, z naught. Very, very, very important, right? We have to remember that. That's probably one of the most important things in this class is the
Yeah, that looks
equation
really
of a
familiar.
plane. Good. So now what you've got with a tangent plane, all a tangent plane is saying is that your normal vector is equal to the gradient vector at that point. That's all it is. It's just a gradient vector at the point.
No, really?
That's it. That's it. That's crazy, right? Because when you write this, you would have like f partial x of the point p naught, x minus x naught, plus f partial y. See, like you just got to explain it to you like this. Hey, that's all it is. I'm just going to replace, my normal vector with my gradient vector. This looks like shit. Equals 0.
Yeah.
It's all right? But see, you get the idea of what exactly you need to do here. Now, if you want to visualize what a gradient vector is, it's not difficult. The gradient vector is a normal vector to the tangent plane. The gradient vector is a normal vector to the tangent plane. That's all it is. And so I always imagine, when I think about a gradient vector, I imagine a fly on a hot plate. You imagine a fly on a hot plate. So like, say you got this plate. What the heck just happened here? Okay, you've got this plate and it's evenly heated. It's a hot plate like you use in the dorm, right? And you got this little fly. This little fly, he's like running along the hot plate, right? If he goes this way, he's not going to cool off at all. Let's call that U. If he goes this way, he's gonna cool off fastest. See, that's your direction of maximum rate of change, is your gradient vector. If the fly walks along the hot plate, if he goes in the direction of the vector u, nothing's going to change. He's not going to cool off at all. If I'm on a hot plate and I just walk along this hot plate, am I cooling off? No, but if I fly straight up in the air, I'm going to cool off the fastest, aren't I?
Yeah.
Okay. So, but notice when I take the gradient vector and I dot it with u, I get 0. Right? That because they're perpendicular, because the gradient vector of f here is perpendicular to u. So any vector inside the plane, if I dot that with the gradient vector, that's going to give me 0 every single time. And then what is the directional derivative? The directional derivative is if you fly off this way, and let's just call that v, your directional derivative of f is equal to the gradient vector of f dotted with v. That's your directional derivative when you're going in the direction of v. That tells you your rate of change. How quickly am I cooling off in that direction? So I find v, I make v a unit vector, and I dot it with f, and I've got myself my directional derivative. And if I'm talking about a plane, all I'm taking is the gradient vector, which is normal vector to the tangent plane. It's a normal vector to the tangent plane. So if I've got some blob, some surface, right, and it's changing, and I take the gradient vector, or if I take the tangent plane, right, what I'm doing is I'm finding the gradient vector. Because, okay, for a plane, the most important thing for a plane is the points and the normal vector. That's all you need for the equation of a plane. All you need for the equation of a plane is the point and the normal vector. Right? The point and the normal vector is all I need for the equation of a plane. So for a gradient vector, the gradient vector is the normal vector to a tangent plane. The gradient vector is the normal vector to the tangent plane. That's all you got to remember. The gradient vector is the normal vector to the tangent plane, right? So you don't need to even understand what I just said, but it does give you some kind of context if you want to think about things. So that if they say, what's the direction of the maximum rate of change? That's the direction of the gradient vector. And now in my solutions, I put the gradient vector as a normal vector. In his solutions, he put the gradient vector. He didn't take the unit vector for the gradient vector. A lot of this is probably not making any sense. But when you talk about direction, right? When I talk about direction of a vector, I can take the unit vector to just get the direction. A vector has two components, length and direction. If I want just the direction, take the unit vector, divide it by its length. If I want everybody on Earth to be 1 foot tall, I'll divide them by their height and feet.
Okay.
Right? So if you want just the direction of a vector, divide it by its magnitude. If you want just the direction of a vector, divide it by its magnitude. Not really that important. Okay. But if I'm looking at this right here and they're saying find the tangent plane and normal line to this whole thing. Okay. First thing I'm going to do is just call this something. I'm going to say big F. I'll say big F is equal to 2x minus 2 squared plus y minus 1 squared. Very easy what I'm about to do, right? Minus 10 is equal to 0. So just make a big F and set it equal to 0. That's all you got to do. Take a big F, set it equal to 0. Right now, I'm going to find all my partial derivatives. So the gradient vector is normal to the surface. The gradient vector is normal to the surface. So f partial x will be 4x minus 2. That's it. F partial y will be equal to 2y minus 1. F partial z will be equal to 2 times z minus 3. That's it. Those are all my vectors that I need, right?
Mhm.
That's it. That's it. Now I have my gradient vector. Now, if I want the vector at that point, I'll take f partial x at my point 3, 3, 5. Let's just call this P. F partial x at P. I'm going to put in a 3 right there, right? So that's going to equal 4.
Understandable. I get that.
Easy, easy, right? F partial y at P is going to equal 2 times 3 minus 1, 4,
What-
right?
Wait.
I'm just plugging in 3, 3, 5.
Yeah.
3, 3, 5. And then for my z, I've got 2 times 5 minus 3. That's going to equal 4 as well. So my gradient vector of f at the point 3, 3, 5, this is my normal vector to the plane. My normal vector to the plane is 4, 4, 1. Now, if I was only concerned about the direction of this vector, right? Like, look at that. That's a little bit easier to deal with. And I can use that if I want to, because all I care about is, you know, but I'm not going to. I'm going to use this guy right here. Okay, so all I got to do is plug that into the equation of a plane. That's all I got to do. What's the equation of a plane? It's the normal vector. That's my normal vector. My gradient vector is my normal vector. My gradient vector is my normal vector. My gradient vector is my normal vector. I'm going to say that. So I've got my gradient vector and I've got my point. This is all I need. 4x minus 3. That's my gradient vector, x minus my point, plus my gradient vector, y minus my point, plus my gradient vector 4, z minus my point equals 0. And I noticed on his solutions, he left it like this. I simplified it on my solutions. You don't need to do that because he didn't simplify it on his solutions. And I know Tynan, he doesn't care about simplification. He cares that you know what the hell you're talking about. Simplification's silly,
Yeah.
right? It's all objective anyways, right?
Yeah.
Yeah, so you just leave it like this and you're good to go, man.
Yeah, sounds good.
So what did we learn? We learned that the normal vector is the gradient vector.
Yeah, I remember that.
Yeah.
I know that.
And if
Uh,
you want the line's really easy. Remember, if you want the rest of this equation is what is the line? The line is a point plus a vector times t. It's a point plus a vector times t, right? So your x of t is the point, the 3 point plus the vector times t. Y of t is the point 3, the y point plus the y vector times t. Z of t is going to be the z point plus the z vector times t. That's it. You focus on the fundamentals, the basics, and everything will fall into place. When you
yeah.
focus on the fundamentals, everything will fall into place. I guarantee it. Any questions?
No, I don't have any questions. I That actually made a lot of sense. Thank you.
Good.
Um, and the gradient vector is the normal vector, right? Or
It's a
something.
normal vector to the tangent plane. It's a
Yeah.
normal vector to the tangent plane, right? It's the direction the fly has to fly off in order to cool quickest if he's on a hot plate.
Go straight up.
Hot plate is your tangent plane. So if he ever asks you what is the direction of the maximum rate of change, that's your gradient vector. And what is that value? It's the magnitude of the gradient vector.
Yeah.
Easy,
That's easy.
easy. And then 18, I drew that one up real nice. If you want to use my solutions for that, if you have a question about some other topic, 18, I'm pretty proud of those solutions.
Okay.
But is there anything else on this practice test you're concerned with?
Let me do one more scan through really quick.
Sure.
I mean, why not? Can we just do like uh I mean I already know, but like just like stamping it in just to make sure. For number 5,
Yeah.
part B or part C.
Number 5. You said D or C?
B or C.
B or C. Okay, so B is G um G of XY is equal to, I'm gonna write it like this because I'm an adult.
Yeah.
There you go. Right. So in one G partial X, remember when you're talking about composition of functions like the chain rule, your partial derivative doesn't care. Your outside derivative doesn't care what you're taking it with respect to. So you go 1/2 blank to the negative 1/2, just like you would in Calc 1,
Yeah.
right? And then you replace your inside, and then you do the derivative with respect to X on the outside. And then G partial Y, notice these will always be the same. These outside derivatives, when you're doing the derivative of the outside, then times the derivative of the inside, your outside derivatives will always be the same with a composite function.
Yeah.
It's a good one to remember. That was B. And then C is going to be f of st is equal to S over S plus 2, S plus T squared. Now, I don't know, man. It's up to you. You can use a quotient rule or you can use a product rule, the chain rule. It's completely up to you.
Yeah.
What do you feel
Could you
more
do
comfortable doing?
uh could you do S like times and then like in parentheses S plus T to the power of -2?
Absolutely. If you're more comfortable with that, and I think that's a good idea. Because when I take F partial T, it's not going to care about the S on the outside. So this is a product rule. So I take the derivative of the first, which is S plus T to the -2. And then I take S times the derivative of the next one. Remember, this is a product rule. We don't care what we're taking it with respect to. And then I take the derivative of the inside. So you talk yourself through those steps. I'm taking product rule. I'm taking chain rule. And when you talk out loud, when you're rehearsing at home in your head, that voice will take over. It's all about training, man. Like you can train people to do incredible things, but you have to train correctly. If I'm just sitting at home going blah, 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 and I'm in my head thinking about dolphins or something while I'm studying, that's not going to work. I have to be saying deliberately, what am I doing right now? I'm taking F partial T and I'm enunciating. I'm saying out loud. I'm doing it, right? This is going to be the derivative of the outside. So that S is a constant. It's just along for the ride. S times -2, S plus T minus 3. I'm saying it out loud. I'm enunciating times the derivative of the inside with respect to T, which is 1. And if you leave it like that, I can almost guarantee that Tynan's going to be like, good job. Because if you simplify that, he's just got to follow you down that rabbit hole for one purpose and one purpose only, and that's to mark it wrong if you make a mistake. When I would be grading tests, right, and students would oversimplify, it would drive me nuts because it's like, dude, now I've got to follow you through that work. If you just leave it like this, I don't have to do anything, right? Like, I'm just going to go check and move on. How many
You should,
people are in your class?
how many people? Probably like 25, 30, maybe only.
Yeah, you got 25, 30 people in there and he's got to grade all that stuff.
Yeah. So
No,
you'd be
man.
okay with like he would be okay with that as the answer?
I would assume I would definitely say yes there. You know?
Okay. Because
He
I feel like I oversimplify sometimes. Um yeah.
and all you gotta do is ask him. You know, you could be taking the test and be like, hey man, is this cool if I leave it just like this? And he'll either say yes or no. You know what I mean? But like you asked,
Yeah.
right?
He says no.
I mean, the worst thing to say is be like, yeah, just can you simplify that up a little bit more?
Yeah.
Yeah.
That's not that bad.
No, it's not. It's not. And you just keep things nice and simple. You talk yourself through this and you just, test is tomorrow at 3 o'clock. You got like 27 hours to just obsess about this. But I'd say about 3 hours for the test, like at noon or 1 o'clock tomorrow. Just call it quits, man. Don't do anything. And the day of the exam, actually starting today, don't do any new problems at all.
I won't. I'm just gonna
Don't
be
do any new problems,
and also
right?
I so I have a class at 1:30 before that. So that's like we'll get my like head off of it. I feel like I don't know.
Yeah. And you focus on breathing through your nose and you just stay cool.
Do you think the gum like study method works?
What's
Like
that?
like when you're like chewing gum and like while studying and then you eat and chew gum while you're doing like on your exam?
Oh, so you're talking about like make things the same. You want the same conditions.
Yeah, I'm just like I don't know. I've heard people do that before, and I was wondering if you think that works.
Well, here's what I would recommend. Say it out loud as you write it. That's the same conditions.
Yeah.
So chewing gum and all that kind of stuff, kind of what you're saying there is like, okay, I'm going to make the conditions of my study the same as the conditions. So if I'm listening to music while I'm studying, I can't listen to music on the test, so that's going to throw me off.
Yeah.
Right? That's what that's saying. But here's what you want to do, man. You want to be, if you want peak performance, I've done a lot of research, a lot of studying, a lot of reading on peak performance. And the idea always is to shut off the default mode network in the brain and go into the parasympathetic nervous state. You want to be in a nice, relaxed delta brainwave state. And I've consulted, there's a neuroscience lab up at UNR, Struthers Neuroscience Lab. I know him. He's a friend of mine,
Yeah.
right? And him and I talk about this stuff all the time. So you want to trick your brain into going parasympathetic, right? So here's what you do. You always breathe through your nose. I mean, I've had classes of 300 students at UNR, and I've looked out where they're taking tests, and I can tell which ones are focused at peak performance and which ones are completely sympathetic. The ones who legs are bouncing up and down and their mouth breathing and they're just like fidgeting and stuff, they're having a sympathetic nervous response. You can't think in that state, right? And if you ever look at anything in panic, you close your eyes, you take 3 conscious breaths, and then you get back to work, right? But before the exam, just find your space, get there like 15 minutes early, find your space, stay calm. Don't run into the exam 5 minutes at a time, panicking, right? You find your space, find your territory, breathe in and out through your nose. Then get out a piece of this is where it's going to sound crazy. You get out a piece of paper and a pencil and you start writing down great and small everything in your life that you're grateful for. I have clean drinking water. I have a bed to sleep in. I have parents that love me. I have this. I have that. Like everything that you can think of. I have both my arms and legs. I woke up this morning. I have a full belly. Anything you can think of. And you do this like for 10 minutes, right? And you write down like 20, 30 things, as many things you can think of. Just write them as many. And it tricks your brain into feeling safe. Because what are we talking about, right? You see the lion, right? You freak out, you run from the lion, and then you hide in your cave and you're like, okay, I feel safe now, right? When we feel safe, we can think clearly, we can retrieve information, we can remember information, right? If you're studying in a panic state, you're not going to remember anything. If you're trying to take a test in a panic state, you're not going to remember anything that you studied, right? So you want to trick your brain into feeling like it's in this nice, safe space,
Yes.
right? And my students that do that, my students that use a gratitude list before their exams, they have all reported back to me they have a different test taking experience because you're nice and calm. You're like, you know what? This isn't the end of the world. It's not the end of the world. I mean, you've taken this class before and it didn't kill you,
Yeah.
right? You get to a problem that you don't understand and you go, you know what? I've practiced these. I've rewritten this practice test 5 times. I've done this before. I can do this again. And that's what you say to yourself. I've done this before. I can do this again. Does that make sense?
Yeah, it does.
Yeah. Yeah. So that's what you want to focus on.
Okay.
Just
Um,
rewrite and talk yourself through it. Rewrite, talk yourself through it. And if you got any questions, you can send me a chat on school anytime.
okay, well. And if I don't know. I can also message you. I have your number.
Yeah.
If that doesn't work.
Yeah. Whatever you want to do. I prefer if you get a hold of me through school.
Yeah.
That's just, because my phone, it just goes crazy. There's too much stuff going on there.
Oh yeah, I
I
won't
can
do that.
focus on my students there. Yeah.
I'll go through school then.
All right, man. And I'll try to let you know. I mean, the live sessions just pop up when I don't have, because I do private sessions with students each week. So I have like a roster of students that I meet with at a specific time each week. So if there's a cancellation or if I'm not meeting with the student, I jump online, but you don't get a lot of, you know, uh, there's not a lot of heads up there, right?
Yeah. It's like a 15-minute warning, you said.
Yeah. But if you ever want to meet with me one on one, just let me know. We can talk about that at some other point, right? That's not,
Is it like another payment that I have to do or
I charge by the session. So for like sessions where but the thing is you want to do them consistently, right? But if we're a I charge 280 per session for a private session, right? And that's when we get on a program and everything like that. But you know what? I don't have a lot of students doing private sessions anymore because the school site seems to be enough,
yeah.
right? So if you ever want to level up, that's cool. If you want to do that for DiffyQ or something like that, but if you stay engaged in the school site, you probably don't need that.
Yeah, I appreciate it. Well, also I feel like this one meeting has definitely been more productive than the past multiple meetings with the other guy that I've been meeting with. So
Yeah. Yeah, I mean, Calculus 3 is tricky. I feel like I didn't really I taught this class for like 5 years before I really understood what was going on. You know what I mean? And I
yeah,
can bequeath that. I can tell you what I've learned real quickly, you know. And I will say, like, so University of Central Florida, for some reason, there's a whole bunch of people from University of Central Florida on there for differential equations. The word spread throughout the class about the school site. So I do sessions just for UCF, and everybody shows up to those sessions, and I'm kind of like their instructor, right? So, I mean, if you talk to students in your class and you get a big group of people on here from UNR in that class that you're in, we can do sessions. You know, we can do like a live weekly thing where we meet. If we get 6 students on there, all from that same class, we can meet every Friday night, you know, and review the week or whatever, or get ahead of the week is what I really like to do.
yeah. I could
So keep that in
definitely
mind.
talk to one of my classmates today.
Yeah,
Talk about
keep
that.
that in mind, man. And tell Tiny and I said what's up, man.
I will.
Yeah. Tell him that you met with me today. Yeah, he's a good dude, man. I really like that guy.
He seems really nice.
Yeah, he's one of the good ones. Yeah,
Yeah, that's for
he
sure.
cares about his students a lot.
Yeah, like I told him about my third time taking it. He's like, "Yeah, we'll get you through it this time." So,
Yeah. Tell him
yeah.
I'm gonna stop down and see him sometime. I miss him.
Okay, well, I'll tell him
All
that too.
right.
Okay, I'll see you.
Okay, I'm gonna stop recording now, and what I'm gonna do, I'm gonna post this recording and I'm gonna post our notes on school.
And the notes, okay,
Um,
good. Thank
yeah, so I probably should have said that in the very beginning that I was recording and then was gonna go. But every time we go live,
you.
we
You
put
did,
that
you
in
did.
school. Okay, good. Good.
Yeah, I just you didn't talk about the notes. So I was like I was gonna ask you throughout the recording. So
Yeah. So, yeah, if you need anything, just hit me up on school, man.
okay, well,
Spread the word. I'd love to have a bunch of people from UNR on here.
yeah,
That'd be
yeah,
cool.
I'm gonna talk to one of my buddies today and see if I can get him on. And then maybe more to come.
Yeah, there you go, man. Cool.
Yeah.
All right, I'll talk to you soon.